Question 10. Given that the function fx is modulus x and fx x power 4 are not one-to-one functions. Okay, so let's actually look at what these graphs look like. Let's sketch a modulus x graph and fx is x power 4 graph. Okay, so you can look at this website desmos.com. So they have a graphing calculator. So whenever you want to learn how to graph, you can take up this one lah. So you can draw your graph modulus x. Okay, so this is the modulus x graph and x power 4. Okay, so you can see modulus x is a nice V shape and it starts from the origin. Alright, so our graph is a V shape here. Okay, and then for x power 4, our graph looks like a quadratic graph, but it's a bit flat at the bottom. Okay, so it goes like that and then flat and then go up. Okay, so now let's check if they are not one-to-one. They said they are not one-to-one, right? Okay, so if it's not one-to-one, what relation is this? So you can see each object only has one image. So whenever x, okay, let's say x is 5 here, it only has one image. But every image, so let's say y is 5, has two different objects. Every single image will have two objects. So this is many to one because one image has two objects, but one object only has one image lah. Okay, so this is a many to one function. And let's look at the x4. Terpadam. Okay, like that. Actually, it'll be more flat to the bottom lah, like that. Okay, so let's look at this. This one, each object also only has one image, but each image has two different objects. So each y has two different values of x. So this is also many to one. Okay, one image has two different objects. Many to one. So what they said is correct lah. They said they are not one-to-one, so they are actually many to one. So determine the suitable conditions in the domain of f so that the new functions become one-to-one. Okay, so how to make this function one-to-one? Right. Now the problem is whenever you have one image, you got two different objects. So if we cancel this one out, then you will only have one object. So what we do is we have to choose this part. This one all we erase. So if we erase this, this will become one-to-one. Same thing goes here. So if we erase this, it will become one-to-one. So what we can do is now we need to determine the domain. Okay. So the domain will be more than 0. Okay, so we can say for x more than equals to 0, it will be one-to-one. Same for this. If x more than equals to 0, it's one-to-one. Okay, you can also write x less than equals to 0. No problem, because when it's less than equals to 0, that means we are erasing this one and we are using this one. So this alone without this is also one-to-one function. Okay, so either one of these answers lah. Right. Oh. Right, let's look at B. So question B is asking to find the inverse function for each of these functions, the new functions, from A. Alright, so the new function from A, this is just y equals to x, or you can say fx equals to x. Okay, this is our function because we've already removed the negative part. So you remove the negative part, no more modulus real, it's just x. And this one is just fx equals to x4. You can't do anything, but you just have to know that the domain is between more than 0. Okay, it's more than or equals to 0. Right, so how to find these inverse functions? To find inverse, the steps are always the same. Let f inverse x equals to y, fy equals to x. So if fx is x, then fy would be y equals to x. So our f inverse x is also x. Okay, if you're confused, give me a while, we'll get back to that. Here, same thing, let f inverse x equals to y. So fy equals to x. If fx is x4, so fy would be y power 4. So y power 4 equals to x. Then you must make y the subject. So you move the 4 over the other side, it will become 1 over 4. So our f inverse x equals to x power 1 over 4. This is your answer. Okay, one more way to find the inverse function is when you reflect the fx on y equals to x axis. Okay, you reflect this on the y equals to x axis, you can find inverse. This is another tip lah. Okay, I write this here. So f inverse and fx, f inverse x and fx are reflections on y equals to x axis. Okay, so if you want to find the inverse function of this, you have to reflect it on the y equals to x axis. So if you reflect the line, it will still stay the same place. But here, if we reflect on this line, our graph is going to look something like this. Alamak, wait, let me use a solid. Okay, so your graph is going to look something like that. Okay, so this is the reflection of fx. So this is their relationship, okay, between f inverse and fx. These graphs are the reflections of each other on this axis.